When it comes to the search for life on Mars, we might be looking in the wrong place. Recently, I was asked by Timothy Walter on Patreon about the most likely places in the solar system to find life outside of Earth. Mars is certainly a strong contender. During the first billion or so years of its existence, Mars shared remarkable similarities with early Earth. It's entirely plausible that life could have emerged on its surface during this time. However, as Mars evolved, it underwent a series of changes that made the planet significantly less hospitable for life as we know it. This is why NASA's rovers, such as Perseverance, have focused their investigations on ancient sites like Jezero Crater. These locations, featuring evidence of dried-up river deltas, serve as potential repositories of clues, remnants of a time when liquid water flowed freely across Mars' surface. The hope is that these regions may hold evidence of past life. But as I delve deeper into this topic, I began to question whether we are focusing on the right locations. Could there be an alternative site, one even more likely to host life, perhaps even to this day? The answer, I believe, lies beneath the Martian surface. I'm Alex Mogan, and you're watching Digital Discoveries, the series where we answer questions from our community on Patreon and explore the science behind them. Today we'll journey into the most promising places on Mars where life might exist, past or present. This will take us deep below the planet's surface, where a deep biosphere might be thriving. By the end of this exploration, we'll attempt to answer one critical question. Where is the most likely place to find life on Mars? Life's beginnings, a universal framework. To understand where life might exist on Mars, we must start at the beginning. What conditions are necessary for life to form, and how does Mars measure up? Life on Earth provides the template. While we don't yet fully understand the precise mechanisms that led to the emergence of life here, there are certain requirements scientists broadly agree on. The three foundational ingredients for life are liquid water, energy sources, and raw materials. Every form of life we know depends on water as a medium for chemical reactions. Energy sources can include sunlight, geothermal heat, or chemical gradients, all of which drive metabolic processes. Raw materials like complex organic molecules, minerals, and elements such as carbon, nitrogen, and phosphorus are all necessary for constructing the building blocks of life. On Earth, the earliest signs of life appeared remarkably quickly, within a billion years after the planet's formation. These first organisms likely arose in environments like deep-sea hydrothermal vents or volcanic hot springs, both settings that provide abundant heat and a mix of minerals, facilitating the chemistry necessary for life. Importantly, these environments also exert selective pressures, such as periodic cycles of wet and dry conditions, that encourage the survival and replication of more robust chemical structures. Mars, in its earliest days, seems to have had all three ingredients in abundance. Scientists believe that during its first billion years, Mars boasted a thick atmosphere capable of supporting liquid water on its surface. This atmosphere was reinforced by a magnetic field, shielding the planet from harmful solar radiation. Geological activity, including volcanism, provided the energy and raw materials needed to create complex chemistry. Vast oceans and river systems likely covered significant portions of the planet. In essence, Mars was, during this period, Earth-like in ways that make the emergence of life entirely plausible. The decline of Mars. Unfortunately, Mars' hospitable conditions didn't last. Around 1 to 2 billion years after its formation, the processes that powered its magnetic field ceased. Without the protection of this field, solar winds stripped away much of the Martian atmosphere. As a result, the planet cooled, its water evaporated or froze, and its surface became an inhospitable desert exposed to intense radiation. The only remaining water today exists locked in polar caps or as trace amounts of brine within the soil. NASA's exploration strategy assumes that if life did exist on Mars, it must have emerged during this earlier, more favorable period. This is why Perseverance is tasked with analyzing ancient sediments in places like Jezero Crater. These sediments could contain fossilized microbial life preserved from when the crater was a lake. Even more intriguingly, some studies suggest that certain microbes on Earth are capable of surviving extreme conditions, including desiccation, radiation, and freezing, for millions of years. It's conceivable then that similar microbial life could be dormant in Mars' ancient lake beds, waiting to be discovered. Going deeper, the case for a subsurface biosphere. While ancient lake beds like Jezero are promising, they might not be the best place to search for extant life. For that, we need to look beneath the surface. Mars' underground environment offers several advantages that could allow life to persist even today. Beneath the surface, organisms would be shielded from harmful radiation and temperature extremes. Thermal vents or residual geothermal activity might provide heat and nutrients, creating stable habitats. Intriguingly, evidence of underground water reservoirs has already been detected. In 2018, scientists using radar instruments aboard the European Space Agency's Mars Express orbiter discovered what appeared to be a large lake buried beneath the southern polar cap. Subsequent studies identified additional potential reservoirs, though their exact nature remains a subject of debate. These underground lakes are reminiscent of Lake Vostok, an isolated subglacial lake in Antarctica sealed beneath 4 kilometers of ice. Despite being cut off from sunlight and external nutrients for millions of years, Lake Vostok hosts a surprising diversity of microbial life. Could similar ecosystems exist beneath Mars' ice caps? The answer hinges on whether these reservoirs are truly liquid and whether they contain the right chemical conditions to support life. Some researchers caution that the high salt content required to keep water liquid at such low temperatures on Mars might make these lakes inhospitable. Others suggest that the radar signals interpreted as lakes might instead be due to unusual geological formations, such as layers of highly reflective dust. The deep biosphere. Lessons for Mars. The most compelling argument for life on Mars comes from an unexpected place: Earth's deep biosphere. Beneath our planet's crust lies an astonishingly vast and diverse ecosystem. Microbial life thrives kilometers underground in complete darkness, feeding on chemical nutrients and tolerating extreme heat and pressure. In fact, scientists estimate that the biomass of Earth's subsurface life is 400 times greater than that of all humans combined. If such ecosystems can exist on Earth, why not on Mars? Subsurface habitats would have been well protected from the harsh surface conditions that developed as Mars lost its atmosphere. The metabolic processes of these organisms are incredibly slow, allowing them to survive for millions or even billions of years with minimal energy. Challenges in future exploration. Finding life in Mars' subsurface is a daunting task. Even on Earth, studying the deep biosphere requires advanced drilling technology. Mars rovers, such as InSight, have struggled to penetrate even a few centimeters into the Martian crust. To truly explore the deep biosphere on Mars, future missions will need to incorporate advanced drilling equipment capable of reaching kilometers beneath the surface. However, the rewards could be extraordinary. If life exists on Mars, its discovery would reshape our understanding of biology, planetary science, and the potential for life elsewhere in the universe. Even if life is not found, the search will yield invaluable insights into Mars' geology, climate, and history. In conclusion, while surface sites like Jezero Crater are logical starting points for the search for life on Mars, the subsurface holds the greatest promise for finding extant organisms. Whether in underground lakes or deep geothermal vents, Mars might still harbor a thriving ecosystem hidden just beneath its dusty exterior. To truly uncover the secrets of the Red Planet, we will need to dig deeper, both literally and scientifically. What do you think? Where would you search for life on Mars? Let us know in the comments where your questions help shape future episodes.